Okay, so let's get started with our first solution architecture discussion. And I'm really excited because we're going to so many different topics all together, and we'll really understand how they fit and what are the challenges we have as a solutions architect. So the first website is whatisthistime.com. And whatisthistime.com allows people to know what time it is. I know it sounds stupid, but at least it's so easy that everyone understands it and we'll be able to talk about it at length. So we don't need a database because it's so simple. Each instance, each server knows what time it is. And we want to start small. We're willing to accept downtime, but overall, maybe our app will get more and more popular. People really want to know the time around the world, and so we'll need to scale vertically and horizontally, maybe remove downtime. And let's go through the solutions architect journey for this app. We'll see a lot of things on how we can proceed. So let's start really simple. Okay, let's start from the very beginning. You're a solutions architect, and you say, you know what would be great? You have a T2 micro instance and you have a user, and the user says what time it is and say, okay, it's 5:30 p.m. Done. This is my app. So we have a public EC2 instance, and because we want to make that EC2 instance have a static IP, just in case something happens and we need to restart it, then I will attach an elastic IP address to it. So this is my first POC. It's working really great. Our users are able to access our application and we're getting great feedback. So now what's happening is that our users are really having a good time using our application. So they said to their friends, hey, you should use this application. So another friend comes in and says, what time is it? And 7:30 p.m. And another friend comes in, what time is it? 6:30 p.m. And so we realize here that our application is getting more and more traffic. Suddenly the T2 micro instance isn't enough. And so as a solution architect, we say, wait a minute, maybe we should replace that T2 micro instance by something a little bit bigger to handle. So that's called vertical scaling. Maybe we'll make it an M5 large type of instance. So what we do is that we stop the instance, we change the instance type, and then we start again the instance, and here you go, this is an M5 type of instance. So what happened here is that it has the same public IP because it has an elastic IP address, so people are still able to access our application, but we have experienced downtime while upgrading to an M5. And so our users were not really happy. During that moment, they were not able to access our application. So this works, but this isn't great, right? So next, we're going really popular, and it's time to scale horizontally. So we get, remember, this application, M5 has one public IP, elastic IP attached to it, and now we're getting tons of users, and so they're all asking what time is it, and so now we want to scale horizontally, so we start adding EC2 instances. They're all M5 large, and they all have an elastic IP attached to it. So now on top of having 3 EC2 instances, we have 3 elastic IP, and so our users, they need to be aware of the exact values of these 3 elastic IP to talk to our instances. And so that's horizontal scaling. We're doing not bad, but we see we're starting to reach some limits. Now the users need to be aware of more and more IPs, and we have to manage more infrastructure, and it's pretty tricky, right? So, okay, let's change the approach. Now we have 3 EC2 instances, M5, and let's remove elastic IP because it's something that we can't really manage. There's only 5 elastic IP per region by default, so it's not a lot. And so instead, our users, what they're going to do is that they're going to leverage Route 53. So we've set up Route 53, and the website URL is api@whatisthistime.com. And we've decided it's going to be an A record with a TTL of 1 hour. An A record means that from a DNS like this, it's going to give me a list of IPs. So remember, Route 53 A record is IP. So great. So the users query Route 53, and then they get the IP addresses of our EC2 instances, and they can change over time. It doesn't really matter because Route 53 will get updated. We'll update it and keep it in sync. And so our users are now able to access our EC2 instances, and we don't have any elastic IP to manage anymore. So using Route 53, we've done some good improvements. But what happens is that now we want to be able to scale, and be able to add and remove instances on the fly. And so when we do remove an instance, what happens? Well, it seems like these users on the top, they were talking to this M5 large instance, but now it's gone. And it turns out that if they do a Route 53 query, because the TTL was 1 hour, they use the same response for 1 hour. So for 1 hour, they'll try to connect to that instance, and that instance is gone. And so here it's not really great, because even though these users are having a good time, and maybe after 1 hour the user will be able to connect to these two instances. They're not having a good time right now because they think that our application is down, and that's really, really bad. So, okay, so this is an architecture and we see the limit of it. So how do we push this a little bit further? So let's talk about adding a load balancer. So instead, now we don't have public instances anymore. We have private EC2 instances, and we're going to launch them in the same availability zone because we don't know any better. So we've launched them manually. We have 3 M5 large instances, and we are following this course, and we said, okay, let's use a load balancer. And you know what? On top of it, it's going to have health checks, such as if one instance is down or not working, at least we won't send traffic from our users to the instance. So, okay, we're linking the two together. So my ELB is going to be public facing, whereas my private EC2 instances are in the back. And so they restrict traffic between these two using maybe a security group rule that we've seen before, using the group as a reference. Okay, that sounds pretty good. So now our users, they're going to query for what is the time.com, but this time it cannot be a record because a load balancer has its IP changing all the time. And so instead, because it's a load balancer, we can use an alias record. And this alias record is perfect because it will point from Route 53 to the ELB and everything will work really great. And so here we change the DNS, but now the users connect to our load balancer and our load balancers redirects us to our EC2 instances and balances the traffic out. And it's really great because now we can add and remove these instances and register them with a load balancer, and we won't have any downtime for our users thanks to the health checks feature. So really, really good. But now adding and removing instances manually is pretty hard to do. So what about we just leverage something we just learned in class and we'll launch an auto-scaling group. So now we have our API on the left-hand side, same thing, Route 53, ELB, but on the right-hand side now, we're going to have an availability zone and we're going to launch private EC2 instances, but this time they're going to be managed by an auto-scaling group. And so this allows our auto-scaling group to basically scale on demand. Maybe in the morning, no one wants to know the time. Maybe at night, when people want to leave work, they want to know the time. So we're able to scale based on the demand, scale in, scale out. And this is really, really great because now we have an application, no downtime, auto-scaling, load balanced. It seems like a really stable architecture, and it is. But what happens is that there's an earthquake that happens and availability 1 goes down. So 1 goes down, and guess what? Our application is entirely down. Our users are not happy. And so Amazon comes and says, yes, it's because you haven't implemented a multi-AZ application, and we recommend you to implement multi-AZ to be highly available. So, okay, we say, all right, let's change a little bit the things. Now we're going to ELB, and on top of having health checks, it's also going to be multi-AZ, and it's going to be launched on Z1 to 3. So 3 AZs for this ELB, and our auto-scaling group as well is going to span across multiple AZ, and this allows us maybe to have 2 instances in AZ1, 2 instances in AZ2, and 1 instance in AZ3. And so the cool thing now is that, oh great, like if AZ1 goes down, well, we'll still have AZ2 and AZ3 to serve our traffic to our users, and we effectively made our app multi-AZ and highly available and resilient to failure. Pretty awesome, right? Okay, how far can we go with this? Let's keep on going. So we have 2 AZ, and we know that at least 1 instance will be running in each AZ. So why don't we reserve capacity? Why don't we start basically diminishing the cost of our application? Because we know that for sure 2 instances must be running at all time during the year. And so by reserving instance, maybe for the minimum capacity of our auto-scaling group, then we're going to save a lot of cost in the future. Whereas the new instances that get launched, maybe they're going to be temporary, so on demand is fine. Or if we're a bit crazy, we can even use spot instances for less cost, but we might have the instances being terminated. And so it's really interesting, right? Because we've seen an architecture going from a very small application all the way to a load balance, auto-scaling group, multi-AZ, health checks, reserved instances type of application. And so to me, that's, as a solutions architect, your journey. It's up to understand what are the requirements and what should we architect in reference to these requirements. And this is what the exam will test you. Now, this is the first architecture discussion. Trust me, there will be many others in the next lecture. But for now, let's just review what we've discussed. Well, we've discussed, for example, what it is for an EC2 instance to have a public IP and a private IP. Where does it fit in our architecture diagram. We've also seen what is the benefit of having an elastic IP versus using Route 53 versus maybe using a load balancer for our application. We've also seen that because of the Route 53 TTL, we couldn't really use A records, so we had to use a load balancer and alias record, and so that would be able to see how Route 53 can fit in this whole picture. We've seen how to maintain EC2 instances manually, and then we say, well, it's too much maintenance, let's use autoscaling group. And you know what? It's actually going to provide us even better costing because it'll just scale on demand and we'll just have the perfect amount of EC2 instances at any time. And then we said, okay, let's go into multi-AZ. We can survive disasters this way. And let's enable ELB health checks so that only the instances that are clear responding do get traffic. And we've seen how to set up security group rules so that the EC2 instances would only receive traffics coming from the ELB. And finally, we said, you know what, let's look at capacity, let's do some cost saving. We always know that we want 2 EC2 instances running at any time, so let's reserve the instances, and that will bring lots of cost savings. And so all this discussion right here, there's a thing called the well-architected framework in AWS, and we'll be talking about it at length as well in the dedicated section. But there's 5 pillars to it, and there's cost, performance, reliability, security, and operational excellence. And so through this discussion, I want to educate you that we have actually seen these 5 pillars. So cost has many different purposes. So maybe we're scaling up our instance vertically. Maybe we're using an ASG to just have the right amount of instances based on the load. And maybe I want to reserve instances as well to optimize cost. In terms of performance, well, we've seen vertical scaling, we've seen ELBs, we've seen auto-scaling groups, basically how we can adapt to performance over time. Reliability, we'll see how Route 53 can be used to basically reliably direct the traffic to the right EC2 instances, and maybe using multi-AZ for the ELB and multi-AZ for the ASG as well. For security, we've seen how we can use security groups to basically link the load balancer to our instances reliably. Operational excellence, how we can evolve from a very clunky manual process all the way to having it fully automated with auto-scaling groups, etc., etc. So really awesome. I think that's a good discussion, and we'll have many others, but as a solutions architect, start understanding what are the technologies we've seen and how they fit together and how they solve problems all together when configured correctly. So that's it. I hope you like. So we are going to be launching our first EC2 instance, and it will be running on the Linux operating system. And to do so, we will do it using the AWS Management Console. That will allow us to get a high-level approach to understanding some parameters for the configuration of your EC2 instances. Then we'll use something called the EC2 user data script to configure our web server, and then we can see how we can start, stop, and terminate our instances just to see how the cloud can be powerful for elasticity, agility, and all these kind of things. Okay, so let's get started. So let's get our first hands-on with the EC2 service. So let's type EC2 in the search bar and go directly into the EC2 console. So what we're going to do is launch EC2 instances. But before we do so, please make sure you're choosing a region, again, that is close to you. So for me, I'm in Europe, Ireland. So we'll go into instances, and we will start our first EC2 instance. So for this, we first have to choose an AMI called Amazon Machine Image. And we have a bunch of different choices right here. We have Quick Start, which is a way to use the AMIs that are provided by AWS, but also My AMIs, as we'll see, we can create our own AMIs. There's an AWS Marketplace for AMIs, and finally, Community AMIs. So for this instance, we're going to use the Quick Start to launch an AMI named Amazon Linux 2 AMI. And as we can see, this AMI is free tier eligible. That means that we will be able to launch it while not spending any money for now. So let's select this instance. And next we have to choose the instance type. So as we can see in the screen, the instance type, there are so many of them. So you can scroll down and see different kind of instance types for this. So there are instance families. And as you can see, they're grouped into different names, and we'll learn about those in this course. But for now, because we want to get started with a free tier, our only option is to choose a T2 Micro. Next, we will configure the instance details. And so for this, we'll choose to launch one number of instance. We will not modify any of the network settings, so we will launch it into our VPC, or virtual private cloud, that is selected by default. And for IAM role, for now, we won't touch anything. We'll select it. We'll leave it as none, but later on, we will have it with an IAM role. And scroll down. The one thing I'm really interested about is the EC2 user data. So this user data is a script that will be launched during the very and only first boot of the instance. And so for this, I have created a little script in the EC2 user data.sh. So you have to copy the script entirely from the very, very top to the very, very bottom. And then you take that script and you paste it here. This is going to launch a web server onto our EC2 instance and write a file to it. Next, we're getting into the storage. So in this is how much data disk is going to be available on our EC2 instance. We'll leave everything as default. And as you can see here, there's a delete on termination option. That means that when we terminate our instance, the disk is going to go away as well, which is perfect. Next, for tags, this is how we can add tags to our EC2 instance. So for example, we can add a first tag named name, and the name is my first instance. And we can add another tag, for example, department, and choose finance. So you can have as many tags as you want. As you can see, it's going to tag the instance, the volumes, as well as the network interfaces. Next, for the security group, we're going to view them in details later on, but we're going to, in this case, create a new security group, and we're going to add a rule to it. So I'm going to click on Add Rule, and I will choose HTTP right here on port 80, and this means from anywhere. This is going to allow us to access the website onto our EC2 instance. So go here, and then we click on Review and Launch. As we can see, we get a warning about our instance security because the group is open to the world. That's okay, this is intended. So we can review everything we've done here, and once we're ready, we just click on Launch. When we launch this, we need to select a key pair. Now, a key pair is something that we'll be using to SSH to log into our instance. And for now, we don't have any key pairs in our account. So what we have to do is to create a new key pair. And then we have to name it. I will name it EC2 tutorial. And then you have to download this key pair. So this file is downloaded. And please do not lose this file, okay? Once you have downloaded it, please do not lose it. We will be using it later on in this course. So when I'm done, I'm going to launch my instance, and the wizard is complete, and now my instance is launching. So I can click here on this instance to get to the link of it, or I can just go on the left-hand side and click on instances to load that screen. So our instance is launching, and the cloud, so the state is pending, but within 10 to 20 seconds, my instance is going to be ready. And here is the whole power of the cloud, is that I can request one instance, and as you can see right now, it's ready. In less than 10 seconds, have it ready. But I could also launch 100 instances like this and have them ready in 10 seconds. So the cloud really allows you to be flexible and to get computing power very, very quickly whenever you need it. So our instance is ready, and we're going to review a few details about it, okay? So first of all, if we look at the name, it says my first instance. This is directly linked to the fact that we had a tag here named name, and the value was my first instance. Another thing we can notice is that if I scroll down, we can look at the fact that the instance type is T2 micro, which is something we chose, and is part of the free tier. And if I scroll again down, what I'm going to find is that the key pair name is EC2 tutorial, which corresponds to the key pair that we have downloaded from before. Okay, and by the way, you can only download it once, so please do not lose that file. Okay, so this is good, right? Next, if we go up, we can see that our instance has what's called a public IPv4 address, okay, right here, and it has a private IPv4 address right here. This is what you should expect if you have a new account. If you don't have a public IPv4 address, it's maybe because you're using your corporate accounts and they disable that. But if you're using a new account just like me, you will have a public IPv4 address. If you don't have one, I'd suggest you get in touch with your corporation so you can follow this training. Okay, so why don't we just copy this public IPv4, and then actually you can just click on open address, and this is going to open a new web page in a new tab to get access to our instance. So now we're connecting to our instance, and as you can see, this is not working. And the reason is, if you look at the full URL in here, it says HTTPS, but we haven't configured secure HTTP. So this is never going to work. You're going to get an error of a timeout. So let's not do that. Instead, and I want to show you the normal type of error you're going to get so that you don't have to reproduce them. Instead, you're going to just copy the IPv4 address, open a new tab, press enter, and now this is going to work. What we get is a response, hello world, from this IP. So the idea is that we have started a web server on our EC2 instance using the little script that on the user data, and it did execute at the instance first boot. And it's very common in programming that whenever you're first trying something for the first time and show that it works, you just respond with hello world. So in this case, I said hello world from, and then here is an IP. So this IP is different from the public IP we used to access our instance. This is because this is the private IP of our instance. So if I look at the value right here and I compare it to the private IPv4, as we can see, they are exactly the same. So we used the public IP to access our web server, but it responded on purpose because I created the script with its private IP. So this is good, right? So we are starting to get a feel for the power of the cloud. But now let's start a new experiment. I'm going to take this instance and I'm going to do instance type stop instance that you can do exactly the same way by just right-clicking on the instance and doing stop instance. And this is going to stop the instance. So in the cloud, you're free to choose whenever you want to have your instance to be running or to be stopped or to be terminated. And so that's the whole power of it. You don't want to leave things running for nothing. Whenever you're using an instance, it is best practice to stop it. So when you're stopping the instance, it goes into a state, stopping, and then it will be stopped. And so while this happens, if I try to refresh my web page, I can see now it's still connecting, but it's connecting and obviously not succeeding because my instance is now stopped. So another thing I could be doing in the cloud would be to say, okay, I have this server, but I don't need it anymore. I'm going to get rid of it. So to do so, we do instance state, and then we're going to, terminate this instance. So instance termination means that you're going to delete it and you'll never be able to get back to it. And it is very common in the cloud to terminate instances. The reason is in the cloud, everything is disposable. And so it is very normal for you to terminate instances, as we'll see when we look at autoscaling, because you don't need them anymore. You don't need them. And so it's common to back up the data before you terminate your instances, but it is very possible. But because in this tutorial, I want to keep on using my first instance, I'm not going to terminate it. Instead, what I'm going to do is to start it again. So I'm going to start the instance again, and we're going to see what happens. So my instance is now running, but if I try to go back to my website and refresh, as you can see, it still doesn't work. And the reason is when you stop an instance and then start it again after a little while, the public IPv4 is going to be changed. So we're going to get a new public IPv4. The private IPv4 will not have changed, but the public will have changed. So when you copy and paste the new public IPv4, press enter, and yet again, I receive my hello world back. So this really demonstrates the power of the cloud. While my instance is running, I'm going to pay for it. And if I stop it, I'm not going to pay for it. And I can terminate my instance at any time I want. I can also request one instance or 100 instances when I want. And so this is really a huge shift in the mindset from traditional IT premises. When you're on premises, you have to order your servers, get it delivered, you plug it into your infrastructure, and you use them for the next 3 to 5 years. But in the cloud, we're talking about seconds, and you can get rid of it at any time when you want. And this huge change, thanks to the cloud, is making IT so flexible that it allows people to run companies with a very, very little IT department. So that's it for this lecture. I hope you. We have seen that EC2 instances are virtual servers in the cloud, and so far we've been using on-demand instances. So these were instances that we need for short workloads that have predictable price. But sometimes with servers, you know you're going to need them for a very long time, and you can get cost savings by saying that to AWS. So the first option is to use what's called a reserved instance. And a reserved instance needs to be used for a minimum of 1 year. So this is commitment. And you can use 3 types of reserved instances. The first one is simply called reserved instances for long workloads. Think of a database. You'll have convertible reserved instances when you have flexible instances, so you want to change their types over time. Then you have scheduled reserved instances. For example, when you know you don't need it continuously for 1 year, but you need it maybe every Thursday between 3 and 6 p.m. for 1 year. Then we have spot instances. They're going to be short workloads, cheap, but we can lose them. They're less reliable. And we're going to have dedicated hosts where you want to book an entire physical server and control the instance placement. So why am I saying all these things to you? Well, the exam is going to ask you questions and ask you to find the best kind of EC2 instance purchasing option based on the case, obviously, to bring the maximum amount of cost saving or to comply with some rules. So let's do a deep dive into each of those to make sure it's very, very clear. So the first one is EC2 On Demand. where you pay for what you use. So if you have a Linux machine or a Windows machine, then you're going to be billed per second for each second the EC2 is running after the first minute. And for all other operating systems, then the billing is going to be per hour when your on-demand instance is running. So this is on-demand pricing, very, very typical of the cloud. With on-demand, you are right in what the cloud is best for. So it's high cost, but you have no upfront payment, no long-term commitment. You can terminate, stop them, start them whenever you want. And these are recommended for short-term and uninterrupted workloads when you can predict how the application will behave, okay? Next, we have reserved instances. So these will give you about 75% discount compared to on-demand. And you have a reservation period. You can choose 1 year or 3 years. If you choose 3 years, then you're saying that to AWS, hey, I'm willing to book this instance for a longer period of time. So AWS will say, okay, I will give you an even bigger discount. Now we have the purchasing option. You can say no upfront, so that means you pay monthly, partial upfront, or all upfront. With all upfront, that means you're going to pay for your servers right now, today, and obviously because you give money today to AWS, they're very happy and they're going to give you an even bigger discount. Then, because it is reserved instances, you have to reserve a specific instance type. So for example, you have to say, I want a T2 micro or I want a C5 X large, these kind of things. So these reserved instances are recommended if your application is going to be in a steady state usage, so a database. So if you know you need a database for the next 3 years, then reserving that instance will bring you huge cost savings. Now you have different flavors of reserved instances. There's the normal one that I just told you about, but you also have convertible reserved instance where you can change the EC2 instance type over time. So you can do, for example, T2 large, C5 large, R5 4X large, who knows? And this will give you a bit less discount because you can change the EC2 instance type, so up 54% discounts. Then you have the scheduled reserved instances. For example, if you just know you need to launch that EC2 instance within a specific time window that you reserve, so you need to have it just for a fraction of a day, a week, or a month, but you still need to commit for over 1 to 3 years. Hope that makes sense. Next, we have spot instances. So spot instances are great because they can provide you the highest discount in AWS. It can be up to 90% discount compared to on-demand instances. But the particularity of these spot instances is that you can lose them at any point of time if the price you're willing to pay for them is less than the current spot price. So what this means is that the spot price changes over time, and you are saying what you're willing to as a maximum amount for these spot instances. So you can lose them. They're going to be obviously the most cost efficient instances in AWS, but if you use them, you need to use them for workloads that are going to be resilient for failure. So what that means is that, for example, if you know you can lose your instance, you're going to lose all your progress or all of your work if you lose that instance. So what types of workloads will be good for this? Well, batch jobs, so data analysis once at a time. Image processing, so if you want to transform images, if you somehow don't transform one, that's fine, you can retry later. Any distributed workloads, so this is the cloud, so the servers can work together in a distributed fashion, and if one of these server fails, the other ones will know how to react to that failure and still work together without the one server that has been terminated. Or, for example, if you have a workload that has a flexible start and end time, a spot instance could be great. But one thing spot instances are really not great at is to run a critical job or a database, okay? Never ever do that, it would be disastrous. Finally, you have dedicated hosts. So I'm going to read you the definition because I think it's the simplest. So an Amazon dedicated host is a physical server with EC2 instance capacity fully dedicated to your use. So we are renting an entire server in a data center of AWS. Dedicated host can help address compliance requirements and reduce costs by allowing you to use your existing server-bound software licenses. So I put it in bold, compliance requirements and server-bound software licenses, because these are keywords that can come up in the exam. Now, these hosts are going to be allocated for your accounts for a 3-year period duration, so you definitely need to be able to commit to them. They're going to be more expensive because you're getting a full server for yourself, and they're going to be extremely helpful if you have software that has a complicated licensing model, or you bring your own license, or if you have a strong regulatory or compliance needs and you want to make sure no other customers of AWS can use that server but you. And so, as you know, AWS shares all their servers with everyone. There is some security to make sure that you cannot see the server of your neighbor, but sometimes because of regulations or compliance needs, you need to make sure that you have the physical server just to yourself. Now there's one last type of dedicated instance, which is called dedicated instances. And these are for EC2 instances running on hardware that's dedicated to you. And you may share the hardware with other instances in the same account, okay? And you don't have control over how the instance is placed. So what it means is that there is hardware dedicated to you, but you don't get access to that underlying hardware. So it's more of a soft version of dedicated host, and I can understand this can be confusing. So as we can see on the right hand side table, there is a difference between dedicated instance and dedicated host. So both allow you to use dedicated physical servers, okay? But with dedicated host, you get per host billing, whereas for dedicated instances, you get per instance billing. And the dedicated host gives you a lot of access to the underlying hardware. So we get these nice server-bound licenses that are to be used on dedicated host because we have access to the socket, cores, and host ID, and so on. Whereas dedicated instances, the only thing that it allows you to give you is automatic instance placement. So dedicated host is a lot more involved. This is more when you have the server-bound licenses. Dedicated instances is if you need some high-level regulatory compliance that you're saying that the hardware will be shared with anyone else. Now, I don't think the exam will ask you the difference between dedicated host and dedicated instances, but it's still good to see in this lecture. The exam will ask you to choose the right instance and to compare it to a hotel, just to maybe give a nice comparison. So on demand means that you're coming and staying in the resort whenever you like and you pay the full price. So you show up and you get your room. But reserved is you plan ahead and you want to stay for a very, very long time in the hotel. You're going to get a good discount because they know you're going to get a room for maybe 1 month. Spot instances is if you're a little bit sneaky. So you know that some hotel rooms at night are going to be empty, and you know the hotel is to give you aggressive discounts because they want someone to stay in that hotel room, otherwise they'll lose that hotel room, right? But it would be a weird hotel, but I have to say that to you. The hotel would be able to kick you out if they find someone who will to pay more for your room than you are. So it would be a weird hotel, but hopefully that shows what a spot instance would be like in a hotel. And finally, the dedicated host would need that you would book the entire building of the resort for you because you don't want to have any neighbors for compliance requirements or because you have a server-bound license. Hope that makes sense. And finally, I'm not going to spend too much time on it, but in your own time, you can look at the different price options based on spot, on demand, reserved instances, upfront, no upfront, which shows you the type of discounts you can get based on different options. And to do so, I used an M4 large in the region US East 1 to give you these prices. So that's it for this lecture. I hope that was helpful. This is something you definitely need to know going into the exam, and I will see you in the next. So let's go and create our first EFS network file system. So let's type EFS and we're in the EFS console. So let's create a file system. And as we can see, we have a very simple dialog, and you can click on create and this will just go ahead and create it. But we want to go through the options. So we'll click on customize to look at all the options for our Elastic file system. So the name is optional, so we'll leave it empty. We can enable automated backups to just have a backup of our network file system, which is nice. And we have a lifecycle management tab. So here we can use something called the EFS infrequent access storage class. And the idea is to say, okay, if a file has not been accessed in 30 days, it looks like it's a file that is infrequently accessed. Therefore, move it to the EFS IA storage class in order to save some costs. And that makes sense. So you can say 7 days, 14 days, 30, 60, or 90. Okay. So we'll just leave it as a default of 30 days. Then we get different performance modes. So we have general purpose or max IO. And general purpose, as the name indicates, is ideal for latency sensitive use cases, such as web serving environments and content management systems. So if you have a WordPress, for example, this would be a great use case. And max IO scales to higher level of aggregate throughput and operations per second with a bit more latency. This is better for a big data or processing, file processing type of use case. So we'll just leave at general purpose for now. The throughput mode can either bursting, and that means that the throughput will scale with the file system size, allowing you for short bursts, or if you want deterministic throughput for your EFS file system, maybe because you know you have a small EFS file system, but you need high throughput, then you can provision how many megabytes you want up to 1024 MIB, so megabytes per second. We'll just leave it as bursting as well. We can enable encryption at rest for our EFS file system and scroll down. Now let's click on next. Very important now are the network access settings. So we are operating in our VPC and we can mount it across multiple different availability zones. So EFS is a network file system and we can have it across different AZ, as I'll demonstrate you in a second. And so for each AZ, you should define a security group. And so right now I'm going to go ahead and create the security group we need. So let's go into the EC2 console and I will go into the security groups tab. So on the left-hand side, create a security group and I'll call this one my EFS demo. And for now, no inbound rules. And I will go ahead and create the security group. Okay, so security group for EFS and create it. So now we'll use my EFS demo into this dialog. So I will remove all these security groups and I will choose my EFS demo, which I probably have to refresh this page. So let me do this right now. I'll refresh this page and very quickly scroll down, click on next, and here we go. So I will choose now my EFS demo right here to be the security group for each different attachment point. So okay, and the last one, my EFS demo. Good. So we'll see what that security group impacts in a second. Then I will go next. File system policy is optional, and this is out of scope, so I will just go ahead and skip this. And finally, we can review everything, so we can review and create. So everything looks good here. We have encryption, we are in our VPC, we have IA enabled, we have 3 availability zones that are going to work with our EFS file system, and they all have the same security that we just created. And I will just go ahead and click on create. So now my file system is creating, and while that happens, I can go ahead into my EC2, and I want to create 2 EC2 instances that are going to be accessing that EFS file. So as we can see, let's go ahead. The file system is created. It is created, and so if we look at the size, we can see that we are using 6 kilobytes, and we'll only pay in EFS for what we're using. So we're using 6 kilobytes, so this is what we're going to pay for. And we can also get some information around the size in EFS infrequent access, so how many files have been moved into that lower, much lower price tier in EFS. Okay, so everything looks good right here. Now let's go ahead and create our EC2 instances. So I'll click on Launch Instance. I will choose Amazon Linux 2, AMI, T2 Micro to remain within the free tier. And then I will choose one instance, and I will launch this one in EU West 2B, for example, as my first AZ. If you scroll down, you can see that there's file system, and you could add your EFS file system here, but we'll not do that. I want to show you how it's mounted, so don't click here. We'll click on Add Storage. We can leave the storage as is, add tags. This is fine. I'll go ahead and create a new security group for my instance, and I'll call it EC2 to EFS, because this is my EC2 instance going to access my EFS network file system. We're going to allow SSH, review and launch, and yes, I have this key pair, launch my instance. So now this instance is launched, and I'm going to launch a similar one, but in a different availability zone. So I right click, launch more like this, and then in my instance details, I will edit the instance details, and I will set it in EU West 2A to be a different availability zone. Review and launch, and launch instance. So here we go. Now we have 2 instances that have been launched in 2 different availability zones, so this one and that one, and we want them to be able to access our EFS network file system. So I'm going to SSH into each of these instances. So this first one is right here. I'm going to launch my SSH command, so EC2 tutorial.pem, and then EC2 user at my IP. I'm into my first host, and I'm going to take this IP of my second EC2 instance and launch a similar command. So here we go, EC2 user at the IP. Okay, so I've done SSH in two instances, and they're both in two different availability zones. Next, I need to install EFS on these instances. So the easiest way is to go back to the EFS console, and on the top right, there's attach. And this gives you some information around how you can attach EFS into your instances. So as we can see, we can mount via DNS or mount via IP. We'll use mount via DNS and use the EFS mount helper. So to use this thing, we have to go into the user guide, the documentation, and install a small package onto our EC2 instances called the Amazon EFS utils package. So we click on installing the Amazon EFS utils package on Amazon Linux too. And as we can see, we can scroll down and do this yum install command. So let's go ahead and do this yum install command onto both my instances. And this is going to install the necessary packages to use this EFS mount helper. Okay, so this was very quick. Now back into EFS. We need to create the EFS directory. So to do so, very simple. We're going to do make dir EFS and make dir EFS. So now if we look into both of our instances, they both have an EFS folder. Next, I'm going to run this command right here to mount the EFS drive using TLS, so they will be in client encryption, and I will mount it into this EFS directory. So let me copy this command right here and paste it, press enter, and as you can see, there is a timeout. That's because we need to modify the security group settings. So let's stop this command, and I'm going to go into my EC2 console, and we need to modify one security group. So if we remember, we have attached a security group into our EFS network file system, which was this one, my EFS demo. And currently my EFS demo, in terms of inbound rules, does not allow anything. What needs to happen is that my EFS demo needs to allow inbound from EC2 to EFS. So very simply, let's edit the inbound rule, add a rule, and we'll look for NFS. And the source of it is going to be EC2 to EFS security group. And so we allow EC2 instances into EFS. We'll save this rule. And now that this rule has been done, we should be able to go back into EFS, try this command again, and then it should succeed. And it has succeeded. I can apply the very same command in here on the right-hand side, and it has succeeded as well. Okay, good. So what did happen? Well, let's go into the EFS directory. So I just changed directly into the EFS directory. And currently, we can see there are no files. But what if I create a hello world.txt file in here? Well, I don't have enough permission, so I will do sudo touch hello world.txt. That should do it. Now, if I look into the files, I have a hello world.txt file here. And if I look now on the right-hand side and list the files in EFS, we can see the same hello world file has been created. So if I do sudo nano hello world.txt to just edit and say hello world from the first instance and save this file. So if we look into the content of this file, hello world.txt, it says hello world from the first instance. And if we look to the content of the very same file onto the right-hand side instance, it also hello world from the first instance. So this file system mounted on the left-hand side and the right-hand side is the same, is a shared network file system, and that is the whole power of EFS. And that's it, very simple. So when you're done with this, you can go ahead and delete the EFS file system, obviously, and you could go ahead and terminate these EC2 instances if you needed to. So you click on these two instances, action, and then terminate, and you'll be good to go. So that's it for me. I hope you liked it, and I will see you in the